Hey guys, so today we are going to start a new chapter that is energy efficiency in thermal utilities and systems. So, in this chapter of energy efficiency in thermal utilities and system, we are going to discuss various systems like boiler, steam system, furnaces, insulation and refractories, heat exchangers, waste heat recovery, HVAC, etc. So we start with boilers. So in boilers, our topic is types of boiler. So these are the topics which we are going to cover in boiler, that is types, feed water treatment, blowdown, evaporation ratio, soot boiling, performance evaluation, reasons for boiling, tube failures, ECM, startup and shutdown. So let's start with types of boiler. So before starting the types, we are going to discuss two definitions. First is energy efficiency and second is boiler. So what is energy efficiency in equipments? So equipments which are said to be efficient if they are utilizing the maximum amount of input energy and wasting less amount, so getting a greater output. So there may be various factors which can reduce the efficiency of equipments. And the second definition is a boiler. So boiler is a closed vessel in which water or other liquid is heated. Superheated steam under high pressure is generated for the purpose of power generation. So that is a boiler. So as we can see that the boiler is classified on types of various factors. So first is flow of water and hot gases. So it is classified under two factors, fire tube and water tube. In fire tube boilers, hot gases pass through tubes which are surrounded by water, and these boilers are low cost and fuel efficient boilers. But its capacity is limited to 17.5 kg per centimeter square. The examples are Cochrane, Lancashire, and locomotive. In water tube boiler, water circulates through a large number of tubes and hot gases are passed around them. Examples Babcock's and Wilcox boiler. Then next is according to the location and position of the furnace. There is external fired and internally fired boilers. So for externally fired and internally fired boilers, the furnace forms an integral part of the boiler structure, and the vertical tubular and locomotive are example. Then in externally fired boilers have a separate furnace outside the boiler and shall be used usually below it. So the furnace is outside and here it is inside. Then next is according to the steam pressure. So if the pressure is low, then it is called low boiler. the pressure is high, very high. So, according to the 22.5 bar pressure, if above that it is high, and below that it is medium and low. So, according to pressure, we have divided the boiler. Then, according to the application, it is stationary and mobile. If the stationary, as the name suggests, that was installed permanently on land, it cannot be moved, and mobile, meant for ocean cargo and passenger ships with an inherent fast steaming capacity. So, mobile boilers are installed on ships and trucks, so where it is used. So, this mobile boiler you might have seen recently uh, in this farmers protest movement where they used to prepare food with the help of these mobile boilers. That is an example of mobile boiler. Then the last is axis of the shell. So based on the axis, it is classified under vertical and horizontal. If the boiler is in vertical and horizontal conditions. So these are the main types of boilers. Then next we are going to discuss feed water treatment. So in feed water treatment, so the water which we are going to feed, means which we are going to insert in the boiler. So how we can conserve the energy from that? So producing quality steam on demand depends on properly managed water treatment to control steam purity, deposits, and corrosion. The quality of feed water directly affects the efficiency as well as safe operation of the boiler. As the boiler working pressure increases, the quality of feed water required is more stringent. The feed water must be sufficiently free from solids so to allow rapid and efficient heat transfer, and it must be non-corrosive to boiler metal. So if we are providing good quality of water, then our efficiency of the boiler will increase. So it is our duty to make sure that the water which we are feeding is free from solids and non-corrosive to the metal of the boiler. The feed water quality is continuously monitored for buildup of TDS. So we need to install a TDS meter which can help us in measuring the quality of water and hardness. So the different water treatment methods are applied to the feed water as per the required quality as specified by the manufacturers. The operating pressure of the boiler and quality of raw water at site are important. So there are total two. So there are two feed water treatment, that is internal and external. So this both we are going to discuss. So in internal, feed water treatment is carried out by adding chemicals to the boiler to prevent the formation of scale, by converting scale forming compounds to free flowing sludges, which can be removed by blowdown. So this method is limited to boilers where feed water is low in hardness, salts to low pressure, high TDS content. So, if these conditions are not applied, then very high rates of blowdown are required to dispose of the sludge, and this become very uneconomical from heat and water loss consideration, that so much of heated water is getting lost. So it is very much important to treat it before heating. Then different waters require different chemicals. So sodium carbonate, sodium aluminate, sodium phosphate, sodium sulfide, and other compounds of vegetables or inorganic are used for this purpose. So proprietary chemicals are available to suit water conditions. Now, so we discussed internal heat or water treatment. Now we'll discuss external water treatment. So it is used to remove suspended solids, dissolved solids, particularly calcium, magnesium ions, which are major cause of scale formation, and dissolved gases like O2 and CO2. So this solids and gases are needed to be removed. So the first stage of water treatment is to remove hardness, salt, and possibly non-hardness salts. So removal of hardness salts only is called softening, while total removal of salts from the solution is called demineralization. It's called demineralization or ion exchange. So demineralization, reverse osmosis, and deaeration methods are used for feed water treatment. So before any of this are used, so it is very necessary to remove the suspended solids and color from the raw water, as they may fall the resins used in the treatment. So pre-treatment includes simple sedimentation in settling tanks or settling in clarifiers with aid of coagulants or flocculants. So pressure send filters, some filters, and spray radiation can be used to remove carbon dioxide, and iron. So to remove heavy metal salts before the water. So these are the main feed water treatments, that is internal and external. Now next we are going to discuss blowdown. That's boiler blowdown. So what is boiler blowdown? So when water is boiled and steam is generated. So when water is converted into steam and any dissolved salts contained in water remain in the boiler. If there are salts which contain water remain boiler, if these solids are existing within the feed water, they will concentrate and may eventually reach a saturation level of solubility, and they deposit out from the solution. So they will deposit out from the solution. So above a certain level of concentration, these solids encourage foaming and cause carryover of water into the steam. So these deposits may lead to scale formation. So inside the boiler, so which may result in localized overheating, or finally cause the boiler tube failure. So the maximum amount of TDS concentration permissible in various types of boiler are, that is, for Lancashire boiler maximum TDS is 10,000 ppm. For smoke and water tube boilers it is around 5,000. Then low pressure boilers 2,000 to 3,000. High pressure 3,000 to 3,500. Economic boilers 3,000. Cold steam boiler 2,000. So, so it is very much important, necessary to control the level of concentration of the solids that is achieved by the process of blowing down. So it is a process where certain volume of water is blown off. So in which we blow off some volume of water content. We blow down water and is automatically replaced by a new fed water, and thus maintaining the optimum level of total dissolved salts. So to maintain the TDS, we blew off some of water and we insert new water. So that is called blowdown. However, blowdown can be significant source of heat loss if improperly carried out. That is, it can uh, waste our heat as we are blowing down the heated water. So there are two types of blowdown process, that is intermittent and continuous. So in intermittent blowdown is done by manually by operating the valve fitted to discharge pipe at the lowest point of boiler shell to reduce the parameters TDS, conductivity and pH, etc. within the prescribed limits, so that steam quality is not likely to be affected. So in this intermittent blowdown, a large diameter of line is opened for a short period of time, and the time being based on a thumb rule such as once in a shift of 2 minutes. So a huge amount of water is discharged in a short time and substantial amount of heat energy is lost. So heat is lost with the water as well. So larger feed water pumps are required to compensate for this loss of feed water. So that pump energy is also increased. The next is continuous. So in continuous blowdown, there is a steady and constant dispatch of small concentrated water replaced by steady and constant inflow of feed water. So in this continuously water is moving out and continuously water is moving in. So once the this this will ensure that TDS is maintained constant and purity of steam at a given load is observed. So once the blowdown valve is set for given condition, there is no need for a regular operator intervention. Even though a large amount of heat is wasted here, it can be recovered. This can be recovered by flash steam preheating of boiler feed. So, how we can recover that if a steam is moving out? So, we can use a counterflow heat exchanger which is moving in water. So, we can extract the heat from the boiler, from the heat, from the feed water which is moving out. So this type of blowdown is common in high pressure boiler. So this is used in high pressure boiler. In intermittent, we are not extracting a heat because it is not a continuous process. It is a manual batch process, batch. We cannot control that how we can extract the heat. So these are the two types of blowdown. So there are some advantages of blowdown. So that is low pre-treatment cost, then reduce maintenance downtime and increase the boiler life, lower consumption of treatment chemicals and significantly reduces the operational cost. So these are some advantages of blowdown. So next we will see some equations like boiler evaporation ratio. So thank you very much.